Nebulas house baby stars in every spiral arm of the galaxy.
These regions are the nurseries for new stars. There are young stars in these regions that are heating up gas clouds that surround them and making those gas clouds glow pink.
Stars are made out of gas, basically, and our galaxy has gas. In fact, our galaxy, you can think of it as having an atmosphere of gas and dust that surrounds all of the stars that we see in the disk. And it's from this gas that new stars are born.
Stars form in nebulas, which are interstellar clouds that are made up of dust, hydrogen and helium gas, and plasma. Nebulas are also known as stellar nurseries. A nebula starts to form a star when it begins to contract under its own gravitational force. As the compression occurs, it forms a rotating globule. As the temperature and pressure continue to increase, the rotation of the globule increases as well, which causes it to collapse. This process takes between 10,000 to 1 million years. This process of collapsing continues, and atoms are becoming closer and closer in proximity. The globule continues to rotate faster and faster, causing the globule to increase its centrifugal force, which leads the globule to have a central core and a protoplanetary disk. This central core becomes the star, while the protoplanetary disk starts to form planets and asteroids by a process of collision. The cloud heats up due to friction, which causes a protostar. This process lasts for 50 million years. If a protostar has enough energy, the gravitational collapse and heating continue to occur, but if it doesn't, an outcome is a brown dwarf, which is a very large but not bright celestial body. Nuclear fission begins to occur when the protostar reaches the temperature of 27 million degrees Fahrenheit. Hydrogen atoms are converted into helium atoms and energy. This energy, which is radiation, prevents the star from becoming any smaller. From then on, the protostar becomes a main sequence star, which is probably the most stable state that it will be in, converting hydrogen into helium. The lifespan of a star varies by star type. A star that is as big as our sun lives for about 10 billion years. But stars much bigger than ours live shorter lives because they use up more hydrogen and helium. Stars smaller than our sun live for a longer period of time. After becoming a main sequence star, it diverges into two paths with three different outcomes according to the size of the star. Depending on its size, it becomes a red giant or a red supergiant. From there, we have three different outcomes. It becomes a black dwarf, a neutron star, or a black hole. Sun-like stars. As a star grows older, it begins to expand. It runs out of hydrogen and then helium. Then the core of the star starts to contract while the outer layers start to expand, cool, and emit less light. This is the process of a red giant star. Helium atoms begin to fuse together, forming carbon atoms and releasing energy. The core then becomes stable because carbon atoms cannot be compressed. The star starts to lose its mass, cool, and shrink because the outer layers start to drift away from the star, forming a planetary nebula. The star then becomes a white dwarf. A white dwarf is a star with no nuclear fuel. However, it radiates the little heat that it has left for billions of years. Once it is rid of all of its heat, it will become a black dwarf. a black dwarf is a dead star. Huge stars and giant stars. Just like sun-like stars, huge and giant stars expand as they grow older. However, they become colossal in size. They become red supergiant stars. The core of the star starts to shrink and become hotter and denser. Fusion produces heavier elements which temporarily stops the core's shrinking. Eventually, the core collapses, compressing the iron atoms together. The temperature of the core sky rises to 100 billion degrees Fahrenheit. A supernova then forms because the atoms' nuclei overcomes the gravitational forces. It is in this process where huge stars and giant stars diverge. If the star is 1.5 to 3 times the mass of our Sun, which is generally the size of huge stars, it will collapse into a neutron star. It would be about 10 miles in diameter with a very strong magnetic field and very fast spin. If the mass of the star is greater than 3 times the mass of our Sun, which is generally the mass of giant stars, the star contracts, becoming a black hole. The gravitational field of a black hole is so strong that not even light can escape it. Scientists believe that there might be anywhere from 10 million to 1 billion black holes formed by the death of a star in the Milky Way galaxy. The life of a star is now over. It went through a very lengthy journey just to die, but its death is not in vain. It will help produce new things in the universe, such as planets.